This is a walkthrough of problem 3 on exam 1 of module 11 in the book Problem Solving Guide for Electromagnetism and Optics. A lens produces a virtual image that is 2/3 as big as the object when the object is 30 centimeters from the lens. What is the focal length of the lens? Draw a neat ray diagram that shows the object, the correct position, orientation, magnification of the image. Include the focal length and label the object and image on the diagram. Only diverging lenses produce virtual images that are smaller than the object. The lens has to be diverging. Remembering the similar triangles, we know that the image must be 20 centimeters from the lens. The object is 30 centimeters from the lens. The image is 2/3 the size of the object. So the image has to be 20 centimeters from the lens. But the equation, the magnification is the absolute value of Q over P. It's given, the magnification is 2/3. And we know the object distance is 30 centimeters, so Q must be 20 centimeters. The absolute value of Q must be 20 centimeters. We can calculate the focal length because we have P and Q. But we have to remember the image distance is negative because the image is virtual. So 1 over F is 1 over P, which is 30 centimeters, plus 1 over Q, which is minus 20 centimeters. We need a common denominator. Let's use 60. So we have 2/60 minus 3/60, that's minus 1/60. And that's good news that the focal length is negative because it's a diverging lens. It better be negative. So we have the focal length, we have the object distance, we have the image distance. We're ready to draw a good diagram. There's our diverging lens, and there's our image, the hungry caterpillar. There's the focal length. Remember, the focal length is 60 centimeters on the other side of the lens. It's negative, it's diverging. The object is half the distance of the focal length. Let's put it there. Let's draw some rays in parallel out as if it came from the focal point. It's a diverging lens. It's going to spread the light out. Then center of the lens. That one doesn't get refracted at all. It's a thin lens. These diverge. In order to find the position of the image, we have to trace this refracted ray backwards through the focal point. It looks like it came from the focal point. The image is where those two lines cross. Right there. Everything seems consistent. The image is 2/3 the size of the object. The image is virtual. It's at 20 centimeters. The object is at 30 centimeters. The focal length is 60 centimeters. Remember, the observer is looking through the lens. It's a piece of glass. It's transparent. The observer is over here looking at the rays coming through the glass. And the observer will see an image 2/3 the size of an object. So now we can answer the question. Part A, what is the focal length? The answer is minus 60 centimeters. Part B asks for a ray diagram. The diagram looks good. It's all consistent with the lens equation. Let's label the object and the image to make sure we get full credit. There's the object, and there's the image. And that's problem 3.